And finally, we've reached the end of the hydrologic modeling process and our flow chart. Here we have our snap, pour, and watershed functions. In terms of what is a watershed, it's quite similar to a basin. However, it's got a little bit more in terms of it can be really anywhere. What a watershed is in GIS lingo is the upslope area that contributes flow to a given cell. It can be a part of a larger watershed. It can also contain smaller watersheds called subbasins. For example, in this particular schematic here, we've got a particular drainage subbasin within this particular larger watershed. But this drainage subbasin eventually comes in as part of this one larger drainage basin we call a watershed. Here, a watershed is separated by a divide from the next watershed. The outlet, or what we call the pour point, P-O-U-R, is the point on the surface at which the water flows out of an area, and is generally speaking, of course, going to be the lowest point along the boundary of the watershed. And going back to our basin from beforehand, these are clearly defined. These are basins in which they're defined by the GIS. A watershed, I could come in and say, okay, right here's my pour point. Where's the watershed from here? Oh, right here. Right here's my pour point. Where's the watershed from here? Whereas the basin are defined here by the GIS and kind of create a mathematical process as far as saying this area is distinguished from this area, whereas watersheds are essentially the same thing, but allow us a little bit more opportunities to kind of go in and put our pour point wherever we want. So let's show how to do this in a GIS. And once again, we're using our Indianapolis-Marion County example. And so what I did here was I went to my folder and I right-clicked on it, and I said, okay, make something new, and let's do a new shapefile. And the result of that here is a create feature class pane. And so I wanted to put this here in my folder I've been putting everything. I call this particular point, point 1, but I could call this pour point, P-O-U-R underscore point, or pour point as one word, could be whatever. You got to change the geometry type to point. It could be it could do a line area, but in this case, I'm doing a point, so I got to make sure the geometry type is changed to point, and then the coordinate system, whatever the current map is. So I just change this to whatever the current map is, and then I click on Run, and it creates a pour point over here in the contents pane. Now what I got to do is I got to highlight the pour point. I then got to go up to the feature layer and then do an edit because I got to now create that sucker. So I got to create this pour point. So what I got over here is the create button. So I click on the create button. So the create button is created, and then over here we have the pour point. Click on that square, and then very important, I then go up to the snapping up here and make sure that the snapping is turned on. Make sure the snapping is turned on. It's very important because once again, we go back to this earlier snap pour. Snap pours where essentially the pour point is being snapped to our flow grid. And so then I go here, okay, where am I going to snap it? So what I did was I went over here because I want to snap right over by the turn 2 of the Indianapolis Motor Speedway. Here's turn 2. So once again, snapping is on, and if it wasn't on, I wouldn't be able to see this stream order 1 vertex notification. I wouldn't be able to see that. And so essentially what I did was then double clicked once I see this being shown, because what that means is now I'm snapped to this particular flow. And so this is right over 16th Street. So here's 16th Street and turn 2 of Indianapolis Speedway. So let's call this the turn 2 watershed. So here's my pour point, my snap pour that I've created. And so I created this particular feature. And once I did that, it creates it, and then I got to X that out. And then make sure, of course, always to save your edits. So go up to Edit, then Save to save your edits. You also might get a notification here in the Create Features pane regarding that as well. And so our create point has been created. Our pour point has been created here. And so now, once again, save my edits. Hell yes. And now let's go ahead and let's now run the watershed. And so now I've got my point. I've got my flow. Now let's create the watershed from this particular point. And so go ahead and go to the geoprocessing pane, do the watershed. In this case, I did the flow direction force as my input. And so my last or my most recent flow direction, and I used the pour point, that point that I just created, I used that as the point data, left the ID, left that as is, and I named this particular raster watershed1.img. You could also just call this watershed. Go ahead and I clicked run, and this is the result. So the watershed was essentially created as one big black glob. Keep in mind, this is raster, so created a raster grid. So this glob here is the watershed. So it's kind of been defined definitely by road networks. This is why it kind of has this curve feature. And so this is something which if I really wanted to play around with the data, I would want to make sure that that there was maybe gaps that would then allow the water to flow across. So essentially what this is the man-made features have created this watershed feature here. It's very much not natural looking at all. But anyway, let's go ahead and let's take this particular raster. And once again, the thing we have to do is we have to go back and forth a lot, from raster to vector, from floating grid to integer. And so here what we're doing is we're now going to do a raster to polygon. So I converted the raster to polygon, used the watershed. So this particular watershed that I just created, my raster grid as the input, the field, I think it was value was the default, left that as is. And I'm going to call this watershed polygon because I'm creating a vector data. So I'm creating a polygon. So essentially what it's going to do is it's going to turn this into a polygon shape, a polygon vector feature. Simplify polygons, pretty much anytime you see that as a choice, go ahead and click on it. And so I did that, clicked on simplify polygons. Now I run the sucker, and this is the result. Now we have it in the contents pane, watershed poly, and so now we have a vector data feature here. And so I clicked off, removed the raster feature of the raster version of watershed. And so what I can now do is I can then take that in symbology, play around with it, make it hollow. So all I did was I just changed the symbology by highlighting watershed poly, going up to appearance, and then clicking on symbology, and then clicking on properties, and then messing around with the appearance and making it hollow and changing the outline color, in this case to blue. Okay, so it's working our way towards what I want to do here. What my objective all along is to be able to identify this watershed, and now what I want to do is I want all the streams within this watershed only to essentially be clipped. And so I want to get rid of all these other ones. I just want the ones that are located inside of this watershed. And so how you do this is you then do a clip. So I just do a search for a clip. In the clip, then what I do is the input features are a stream order, our stream feature. And then the clip features would then be the watershed poly. So essentially that's the cookie cutter that's going to come in, it's going to cut out, and it's going to keep just what's inside of this particular polygon. I'm going to call it stream order 1 underscore clip. And so I run that tool. And so now I've got a watershed in which I have within it my streams that I want. Only the streams within this particular watershed. All the other ones have been removed. There's a couple things we can do now. Let's go ahead and let's right click on the watershed poly. And what we'll do is you'll zoom to layer so that essentially the map is centered using the watershed as the center point. So that's how you can kind of help to center a map, kind of get it out of the left and put it more in the center here. What we can also do is we can then adjust the stream order clip so that it relates to the Strahler method, the stream ordering that we did earlier. And to do that, essentially what you'd do is you'd make sure that this entry was highlighted, then go to appearance, symbology, and what you should see is something like this over here. What I did was I adjusted mine so that unique values was then shown, and then changed the field 1 to the grid code. Remember, the grid code is essentially the storage code for the Strahler method that we identified previously. And so the color scheme doesn't matter. What I then chose different colors, but also thickness. And so the purple or pink is thicker. And all that I just essentially adjusted, and you can do that by just clicking on those and then changing the symbology and messing around with them in other ways. That's always up to you in terms of how to symbolize your own spatial data. And so what I did here is then with it being centered, of course, with also the stream orders now shown, now underlying this, let's go ahead and remove the world imagery and click on the Marion County, the DEM, and have that as my base map, which remember was the input that kickstarted this all. And so now what I've done is I've identified the turn 2 in 16th Street Watershed. I identified the stream order, so the pink being order 2 and the blues being order 1. I identified a pour point that was snapped to the flow grid, which was once again the stream order or the flow grid, the stream grid. And then of course I also delineated the watershed, essentially divide that separates this watershed from the next one and so forth. And so the lowest point anywhere along this boundary would be our pour point.